Hey guys, this is a quick video to show how to use Solver in Excel and produce output and reports. Looking into this problem, Meadow Products makes automobile radar detectors and assembles two models, Laser Sharp and Speedmaster. Meadow sells everything they do. Both models use same electronic components. Two of these components can be obtained only from a single supplier. For the next month, the supply of these components is limited to 4,000 of component A and 3,500 of component B. The number of each component required for each product and the profit per unit are given in the table below. And the reason for reading the problem description is to be able to extract the objective function and the constraints that we will use to fill in the solver dialog box to run the solution. So the table says that Laser Sharp model will use 18 units of component A and 6 units of component B to make $24 per profit per unit, and Speedmaster we will need to use 12 of component A and 10 of component B to make $40 profit per unit, and is asking us to identify the decision variables, the objective function, and the constraints, and then mathematically formulate a linear optimization model. In this sheet, which is prepared for you, is we try to extract the information and see if we can run the solution. The decision variables is basically how many to produce of the Laser Sharp model and the Speedmaster model, and we will put that as an L, as an S, and S just to ease of typing. The objective value here is to maximize profit, making $24 per each unit of Laser Sharp plus $40 profit for each unit of model Speedmaster. The constraints is that using 18 for each unit of Laser Sharp plus 12 units of A component A for S does not exceed 4,000 units of A. The availability of B does not exceed 3,500, and of course the L and S cannot be zero or non-negative. They can be zero, but they cannot be negative. In the first thing we do is we try to create a table for the decision variables. So we put here if Laser Sharp was zero, how many units we will need from component A to produce a maximum profit. And it's a very simple calculation that we obtained from here. If 18L in this availability of A equation was zero, that will leave us with 12S equal 4,000. So S is basically 333. So that's what we need to maximize the profit, and the profit per unit is 40. And we go back down here and we create a table for the constraints. The constraint says 18 of A times 0 plus 12 of B times 333 cost. That produces 4,000 units of A, and which actually matches the right hand side. So if we run this constraint, we get 4,000 units, and in this case we use 3,300. If this is a 0, 6 times 0 plus 10 times 333 will give us 3,333, which is less than the 3,500 of the constraints, so the constraints look good. This is a quick view of the output results that makes a net profit of $13,000, and show us that this is the number of component A used has zero slack, meaning it's binding because the right hand side is equal to the left hand side, and component A utilization is not binding because we have an additional 166 units left over are not used because this is less than 3,500. Now, when you fill in the solver, you use all of this first, and I kind of explained everything, but what you need to do is fill in the solver parameters. The objective function is A18, and A18 is right here, and this is what you need to maximize and have solver give you the final profit here. And so if you go here, this is the type of formula you produce a sum product here between this times 0 plus this time 333, and that's what you need to maximize. So you do the sum product and leave it there for Excel to know it, and then type that cell in solver as a solver parameter in the objective function. And the changing variables, you will put B11 to C11, and this is B11 to C11 because this is the cost associated that you're trying to, or the numbers that you're trying to change to arrive to an optimal solution. And in the constraints, you will click first add constraint, and then you will follow. So we're going to try to do that here now. First, we go to data and then solver. And then solver, you will find that we have A18. So basically what I'm going to do, if this is blank, I've never used that before, I will just plug in A18. And if this is blank, I will tell solver that these are my decision variables. Obviously, if you have a bigger problem and you have a bigger table of decision variables, you will include all of them. And then supposedly I don't have that here. I will say add, and then I will say go to 1814, I mean D14, to D15, and it will not let me do it because I have it in already. No, it's okay. And then I say the constraint is 4,000 and 3,500. So now I have, all I need to do is hit OK or hit add, and that will, if I hit OK, it will add the same thing again. So this is because I had it already previously made, but we will need to remove one of those. So once you have this solver built in, you will go ahead, as you see, we have it here built in, and I need to change that. Cancel, I need to delete the new one. So now I have, because I added when I was trying to show you how to do it. Now I have the solver parameters filled in. All I need to do is just, and I need here, I get the simplex method. That's what you need to choose, and then hit solve. And then while you are here, the keep the solver solution is selected, and then you will hit this one, hit the control button, and select all of them if you need all of them, and you just hit OK, and it will bring back all the solutions reports that you need out there, the answer, the sensitivity, and the limits. We already have those here produced, so we'll look into these. This is the answer, which tells that the final profit is $13,000. The decision variables, the components, the number of laser sharp models produced is 0 to maximize the profit. That was the original value started from, and the number of units of the Speedmaster model to maximize profit was 333. And this is the constraint side that says in the number of component A used, we have 4,000 units, and it's binding because we have 0 slack, and the number of units of component B that is used, we have 3,333, which is less than the 3,500 of the maximum allowed. That gives us an extra of 166 units. We call that slag, and therefore this is not binding, or just an expression to say it's not binding, meaning it's not equal. The sensitivity report gives us a range. Here you have a range of that you change. For example, on the decision variable, you can change them to increase them by that amount or decrease them by that amount. It just gives us a range. and that is changing within this range produces the same results, same sensitivity. So this is checking how sensitive is the changes, or what is the impact of the changes. The same thing for the constraints. You can decrease or increase the constraint values according to this range and keep same results. And this is what is called sensitivity report. And the limits report, again, it looks into the number of models produced and the profit and how many units are needed to maximize the profit, and the limits on the profit is shown as well. With that, it concludes the output of Solver, and then you can use the results towards the problem that you had or make changes if you need to. Thank you.